This video is the final one in the series of volume of three-dimensional shape, and our awesome shape for today is volume of spheres. And so sphere is used and seen by you guys every day. If you're playing football, if you see a balloon, tennis, ping pong. So there are quite a few real-life scenarios of spheres. So for the volume of sphere, we are using formula that says 4/3 pi r to the third power. Yes, it is very, very interesting formula. We've seen some of our traditional values and some of our new values. So we're going to spend some time with this formula and put it to work. I do want to make sure that we know if we have a half of the sphere, we call it hemisphere. And so just like with semicircle, we'll be dividing the volume by 2 if necessary. Let's take a moment just to talk about this formula, because I know it looks overwhelming. How in the world would you treat this number or insert this number in the calculator? How would that work? And so on. So we have, if a cylinder and sphere have the same radius and the same height, these two particular shapes, that's what they were referring to. Like how in the world the formula came about. Okay, what specifically is happening? So our formula for volume of cylinder, we know we have area of the base times the height. We specifically have been breaking this down into this process. We said, well, this is B. But when we are working with our values, it's pi radius squared. Okay. Area of the base. Area of the circular base. So what is happening with our sphere? Sphere does not have a base. Some might say, well, base value could be in the center. Yes, maybe, but the official base, as we used to see, is not present anymore. Okay. The spheres also do not have an official height measure. Okay. So in the second step right here, it says replace height with 2r. What do they refer to? So with our previous analysis, we would say, well, these are the two bases of our cylinder. So the height between the two bases is the distance between the two bases. That's what we refer to. So when we come back to our sphere, from this value to this value, this is your r, this is our r. So yes, in reality, that is a height of a sphere. So if you were to create a box, I'm doing terrible job drawing, but if you needed to put a sphere in a box, you would say, well, how tall should it be? How much space? So it does represent the height. But in our formula, now we are seeing pi r squared times, instead of height, we would write 2r, because that's the representative of the height. The relationship between cylinder and sphere that have the same measurement always has, this is 2r, always has the value of 2/3. So the sphere has 2/3 of the volume of the cylinder. So this is just a given value to us because they've done experimenting and measurement and determined this value. So in other words, if we know that the sphere is 2/3 of the area, of the volume of the cylinder, this is where the formula is coming from. Okay? You might say, wow, we're going from bad to worse. Well, let me write it in a nicer format. 2 times pi times radius squared times 2 times r divided by 3. So again, why am I divided by 3? Because this is 2/3. You multiply by 2, divided by 3. And this is how, if you simplify the numerator one more time, 2 times 2 is 4, 4 pi, r to the second power, and r to the first will give us r to the third over 3. So yes, in your formula chart, you're going to see this as your original number, and as you practice, I really want to make sure that you use in this format. It's a lot nicer. All right, let's take a moment to go through some of the examples. I'm going to go ahead and zoom in so you can see all of those steps. So example number 1, we have a radius of 3. So I know it's a sphere and it's a very new shape to us. We have not worked with sphere. We've played with it and we know it's a sphere, but it's new to us. However, the measurements of the spheres are very similar to the ones of the circle. We only going to look, and you can see both of these scenarios back to back, either measure of radius or measure of diameter. So as a reminder, radius is the measure from the center just to the edge of the circle, but diameter goes through the center. It kind of cuts your shape into equal parts. All right, so once again, let's start with writing our formula. 4 pi r to the third divided by 3. This is, again, very unique formula. It's only going to, these numbers and the third power is only going to be applying to spheres. And of course, don't stress about remembering this on your assignment or quizzes. You're always welcome and should be using all of your notes and star chart. So let's plug in our values. 4 times pi, and let's talk about this radius to the third power. It truly is multiplying the radius by itself 3 times. And then we would be dividing by 3. And so that's going to give us 113.1 units cubed. So my huge request, when you're writing this down and then doing your work, using your calculators, make sure that you're writing your steps out first so you can see what number should come in second, third, and so on, and not making silly mistakes. All right, example number 2. So side-by-side comparison, this is radius and this is diameter, as we discussed. However, do we use diameter value? No. We have been really consistently clarifying and making that adjustment. So we are using radius. It's going to be measure of 6. All right, so let's set up our formula. 4 pi radius to the third divide by 3. 4, and I'm just writing pi because we do know the value of pi, 3.14. We do know how this works. So radius would be 6 to the third power. So remember that your exponents are still your priority during order of operation. So first you would say 6 times 6 times 6, or 6 to the third power, and then multiply by pi, multiply by 4. And then divide your product by 3. And yes, we are going to have large numbers a lot of times. And it's again units to the third. All right, one more example. I would like for you to take a moment to see if you can set this up and just kind of go through what is my formula, how does it work. I know this is only the third example, but we have been working with the pi, the radius, and this is ready. This question is ready. There's only one measurement. And I know it seems very crazy, but our formula actually has everything that we need. So 4 and pi, we know the pi, we know 4 is part of it. We're going to take radius to the third power, and then we're going to find this product, and then we're going to divide it by 3. So if you would please pause the video, see if you can plug in and determine the volume, and then come back in when you're done. Unpause it when you're done to check your answer. I hope your answer matches mine. At this point, please take time to not review, but try other questions that have to do with volume of spheres, cones, and cylinder. Make sure you are writing down your steps. So if you have any questions, you can double check things with me and I can help you find the mistake. You got this. Great work.